All right, so as requested, we are also going to be looking at how to solve banked track questions that also involve friction. So, harder bank track questions involve bank tracks with friction. However, these types of questions are extremely rare and often only come about once every few years in very selective school trial exams, okay? So typically these questions involve addition of friction and how they relate to vehicles on bank tracks, right? So essentially what we're saying is these questions are really, really rare, right? So because of that, I'm just gonna show you how to do the questions, but we're not really gonna go look at any examples. So recall that friction is produced when a car turns its wheels, right? That's what we've learned in module 5, okay? This is usually done to provide a lateral friction force which helps the car moves sideways. So if you remember about what we learned with cars traveling around a roundabout, right? When a vehicle is traveling around a roundabout, it has to turn its wheels to provide that frictional force in order to make the turn. Okay, similarly, when you're on a bank track that has friction, right? Where does the friction come from? It comes from you turning the wheels, yeah? Okay, so therefore, in some cases where the x component of the normal force is not enough to maintain uniform circular motion, vehicles may also turn their wheels to supply additional frictional force to aid in UCM. So, for example, what does that mean? Or what does that look like? So let's say we have a bank track like this, okay? And we have a vehicle that's, which we're gonna represent by this dot over here, right? It's traveling around a circular path as shown by, this red dotted line, okay? Now, I'm not gonna keep it there, I'm just gonna show, I just draw it to show you how it's gonna rotate, how it's gonna move, but, it's gonna travel around that path. Okay, so, typically, we know that when we have bank tracks, we always have the normal force, which is perpendicular to the surface, and we also have the gravitational force, mg, okay? So that's what we've learned so far. However, question, what do you think happens? Let's say, for example, the common example that I always give is, let's look at a velodrome, right? Okay, let's say the second guy, right, this is you. This is you. If you want, give me a second. So let's say the second guy, right, wants to overtake the first person. How can you do this? You have to turn your wheels to cut through, true, right? But in order to turn the wheels, if you want to travel faster, you need to have more sideways friction. So in other words, vehicles need to turn their wheels in some cases, even on bank tracks, because they want to travel faster, right? Or a smaller radius, or have a sharper turn. Does that kind of make sense? So there's many different reasons why. We turn our vehicles, all right? Or we turn the wheels, okay? So let's say you want to travel faster. You're going to turn the wheels inwards, which is going to create a frictional force that is going down the plane, right? And so whenever we are dealing with a bank track questions with friction, okay, they can either be down the plane or up the plane. It just depends on the question. So therefore, when these problems arise, all you have to do when you have an extra frictional force, right, is you just add the components to the x and y axis and then resolve. So just like before, what we did was to solve bank track questions, you look at the net force in the x-axis, you look at the net force in the y-axis, and you solve, okay? So here's a rule. Step 1. You ask yourself, what is the object doing? The object is traveling around a circular path. Therefore, as you can see here, the net force in the x direction must be equal to mv squared on r. Right? And then you ask yourself, what is the object doing in the vertical direction? Does the object move up or down? No. I'm just turning my wheels, okay, to travel faster. So, if the object is stationary, not stationary, if the object doesn't move up or down, the net force in the y-axis is 0. Okay? So, here are your forces, right? Or these are the what you have. These are your equations. Then, step 2, we always ask ourselves, okay, now we need to resolve, right? We have 1, 2, 3 forces. Okay, so how do I break them up? So Fn has an x component. What's the x component of Fn? So remember, this angle here is theta. This angle here is also theta. So the x component of Fn is Fn sine theta. So that's going to be equal to Fn sine theta. Okay. Do we have any other additional forces in the x-axis? Yes, we do, right? Now, because we have friction, we have to add the x component of your frictional force. So that means that if I draw a horizontal line, you can see that this angle here is also theta, right? Due to alternating angles. Okay, so the x component of your frictional force is now Ff, right? Your frictional force towards the angle cos theta. So that's going to be plus your frictional force cos theta. Okay, is that it? Do we have any other x components? Okay, check. No, that's it, yeah? We only have 1, 2, done. Okay, then we got to take a look at the forces along the y-axis. So, in the y-axis, how many forces do we have? You have Fny, Ffy, and Mg, okay? So we plug it all in. That's going to be Fn cos theta minus, because the frictional force is downwards, yeah? Minus the frictional force sine theta. And then here, because your gravity or gravitational force is also down, we say minus mg. Okay, and there you have it. These are your two equations that describe how the object is going to behave, right? And then from here, once you have these two equations, all you have to do is solve for what you're looking for. Now, usually, the question will always give you the frictional force, so you can just plug it in. However, if they don't, you might need to go and find it. But guys, look, to be honest, from here, right, it's just algebra, yeah? Okay? That's it. There's nothing else, nothing special, right? So this was step 2. Step 3 is resolve. Okay, or use calculate your unknowns. Make sense? Cool. All right, so that's it for this video. Like I said, it's a very rare scenario where you might have these types of questions. So we're not going to be looking at any examples. All right, so that's it from me. I'll see you guys in the next video.